When you buy a coffee with a tap of your phone, it feels instantaneous, a perfect frictionless exchange of digital currency. But the moment that signal leaves your device, it hits a wall of time. Your sleek iPhone is forced to translate its request into a language written during the Kennedy administration. This chart shows how almost all of our daily financial interactions, 80% of in-person banking, and 95% of every ATM swipe on Earth funnel down into a single bottleneck. All of it relies entirely on a language called COBOL. Silicon Valley has warned for years that this dependency is a disaster waiting to happen. The popular narrative paints global infrastructure as a fragile house of cards, propped up by decaying zombie code. If this architecture is truly a ticking time bomb, you have to ask why a multi-trillion-dollar banking industry hasn't replaced it with modern cloud computing or AI. The answer is that the modern web we interact with every day is an illusion. It is nothing more than a thin layer of glass resting on top of a 60-year-old industrial foundation. Banks are not keeping this code active out of laziness or to save money. Many of them have spent fortunes trying to delete it. There is an entire graveyard of billion-dollar migration projects. When institutions like TSB Bank in the UK attempted to tear out their legacy systems and modernize, the result was hundreds of millions of dollars in losses and total operational blackouts. The reason for these failures comes down to how modern computers actually think. Languages like Python or Java rely on binary logic, ones and zeros. This visualization illustrates the problem with binary when applied to finance. It struggles with floating point math. Ask a modern processor to add 0.1 and 0.2, and it occasionally creates a microscopic decimal error. Across millions of high-speed transactions, those tiny fractions compound into massive financial discrepancies. COBOL sidesteps this entirely by using fixed-point decimal math. It counts pennies exactly the way a human brain does, locking values into rigid, predictable structures that never drift. For the highly specific task of counting money, this ancient language is mathematically superior to the technologies invented yesterday. Keeping this code alive is a strict requirement to prevent the global economy from miscalculating trillions. That software requires a physical host to function perfectly. Today, that host is the monolithic IBM Z-series mainframe. The architectural DNA of these specific machines traces directly back to the height of the Apollo era. IBM engineers their hardware with a religious devotion to backward compatibility. A piece of logic written for a vacuum tube computer in 1964 can run flawlessly on a hyper-advanced 2026 processor without altering a single line of code. We haven't failed to upgrade our infrastructure. We have built a digital eternal city, engineered from the bedrock up to endure forever. There is a mathematical principle called the Lindy effect. It states that the longer a non-perishable thing has survived, the longer it is guaranteed to survive into the future. Viewed through this lens, 60 years of continuous operation is proof of perfection. This code is the ultimate untouchable survivor of the digital age. But while the software and the machines are bulletproof, there is a fatal flaw in the ecosystem. It is biological. The financial sector is quietly facing the Greybeard crisis. When emergencies strike, institutions are forced to track down 80-year-old retired engineers, paying them exorbitant hourly rates to diagnose the problem. The original documentation for these systems was lost decades ago. These aging human beings are the only entities left on Earth capable of translating the architecture. The code itself will endure. The actual existential threat to the modern world is digital amnesia, the rapidly approaching expiration date of the last humans who know how to speak to the